You don't know how to prepare for a job, you don't know how to prepare your resume, and you don't know whether you're prepared for the company or not. Don't worry, Topment will help you to check out whether you really stand out in the interview or not. Simply, you need to go here and search a thing which you want to have. For example, mock interview, resume review, career guidance, or interview preparation guidance. Hello guys, welcome to the another video of linked list using Java. So in this video, we will be start solving the questions on single linked list. Previous 2 to 3 videos we have seen how to implement the single linked list, what is single linked list, and we have performed 4 different operations on single linked list. That is how to insert a node at the start, how to insert a node at the end, and how to traverse the linked list. If you haven't watched that video, I highly recommend you to go and watch the videos of how to implement the single linked list. So in this video we will be solving a question called as count the nodes in a single linked list. So we will be starting with the basics question to build up your intuitions. So what does question says that you will be given a linked list and simply we need to return is how many total number of nodes are present in my linked list. For example, if you observe carefully that in this linked list we got total 4 nodes, so we have to return 4. So let's try to understand how we can count the total number of nodes present in our linked list. So we have already discussed that along with the linked list they will always give a special node called as a head. Now what does head basically do is head always points to the first node of your linked list. Why? We have already discussed in our previous lectures. So head will give us the starting point of linked list. The second important point, I told you that not to change the head pointer. Not to change the head pointer. The reason behind this is if you try to change the head pointer and let's suppose if head is pointing initially to the first node and if it started pointing to this node, then what will it indicate? It will simply indicate that this is your starting node of your linked list. But actually the 1 is our starting point of our linked list. So what basically I will do is I will simply take a special pointer or a temporary pointer which we call as a temp and we will simply assign it with the head. So as of now if you observe carefully my temp is also pointing to my first node of your linked list. Okay, now since my temp is pointing to our first node of linked list, what I will do is I will also keep a counter which is initially equals to 0. Now what I will do is I will keep incrementing my counter as I am moving forward to traversing the node in my linked list. So I am standing at the first node, so simply I will increment it by 1. Then I will move my temp to the next node and now simply I will increment my counter by 2. Again I will move my temp to its next node and I will increment my counter by 3 and again I will take it to my last node of the linked list and I will simply increment my counter by 4. And if I take my temp to the next node, it will simply point to the null. And what does a null indicates? We have already discussed that the null simply indicates that this is the end of our linked list. So we are standing at the end of our linked list and finally we got the 4 as an output, which means the total number of nodes present in our linked list. Now let's check out how we can move our temp from one node to the another node and at the same time how we can. So what I have done is we have taken the same linked list which you saw earlier, that was same I have took. So what we discuss is we need to have the temp pointer which is initially pointing to a head. So if you observe carefully that my temp is also pointing to a first node of the linked list. Now one thing is for sure that say for example we have given a node, we know that the first part contains the data and the second part contains the address. That is address is nothing but that address of the next node, right? And let's suppose the name given to this node is called as a node and we have already discussed that if you want to access any part of your node, how we can access it? We can simply access it by the name of a node and dot the part which you want to access. Now let's suppose if you want to access the address part, so simply what we can do is name of the node dot operator and address part. So this is how we can access this address part, right? In same way we will be using to move our temp pointer to the next node. So as of now our temp is pointing to a head. So what basically temp contains? So temp basically contains address as 100. That is, it is pointing to our first node. So simply what I will do is I will increment my counter from 0 to 1 and now what I will do is I will simply take my temp equals to temp dot next. Now what will indicate it? So initially my temp is pointing to first node. Okay, the temp dot next which is nothing but 200. So my temp will contain now 200. Therefore my temp will be moved to our next node. And now again my temp is pointing to a node, right? It is not pointing to any null pointer. So simply again I will increment my counter as a 2 and again I will do is temp equals to temp dot next. So temp equals to temp dot next is nothing but 500. So simply it will contain a 500 and now my temp will point to this location and again my temp is pointing to a particular node. It is not pointing to a null. It is not pointing to a null. So simply I will increment my counter by 1, so it will become as 3. So again I will come over here and I will see temp is equal to temp.next. So temp equal to temp.next is nothing but 300. So it will be start pointing toward 300, which is nothing but to its last node. And again I will simply increment my counter. Now again what will happen is I will come at this point, that is temp equals to temp.next. Now temp.next is nothing but null. So if I do the temp.next, my temp will start pointing to a null. Now what does this indicate? That this simply indicates that this is the end of our linked list. So since we are standing at the end of the linked list, do we need to increment our counter? No, because we are not pointing to a node of the linked list, we are pointing to the end of the linked list. Therefore we will not increment our counter. Let's try to write the code for this. How you can write the code for this? So basically what will happen, let's suppose they have given a function called as a count nodes, right? They have given a function called as a count node, and in this they have passed the head of the linked list. Do always remember that whenever you are solving the problems on a linked list, they will always give us the head of our linked list. So basically what we'll do is we will simply keep the temporary pointer, which is nothing but the temp, which is initially pointing to a head. Also at the same time I will declare a counter which is called as a CNT, which is mainly used to count the total number of nodes present in our linked list. Now what I will do is I will keep on moving to till next node till my temp is not equals to null, which means till my temp is pointing to any particular node, I have to move forward. And at the same time I will do count plus plus, and I will move my temp to its next location, that is temp equals to temp.next, right? And at the end, once I come out of while loop, I will simply return my total number of nodes, that is count variable present in my linked list. So this is a simple code. Now what will be the total time complexity of this code? If you observe carefully that what basically we are doing, we are moving from each node of our linked list. We are traversing every single node present in our linked list. So we can say that if there are n nodes present in my linked list, the total time complexity of my code will be nothing but big O of n. Now what will be space complexity? Space complexity would be big of 1, because we are not using any extra space to count the total number of nodes present in our linked list. So let's go on to the IDE and try to write the same code which I have written on the iPad. So this is a code which we discussed, that is count linked list in nodes. I will give the problem link in the description box. So basically what they have given us, they have given us a head of the linked list. As we discussed, I declared the temporary pointer which is initialized with head. I took a counter called as a CNT to count the total number of nodes present in our linked list. I moved my temp till it's not equals to null, which means still we are not to the end of our linked list. Keep on moving forward, and at the same time if you are moving forward, keep increment our counter, and once you come out of this while loop, simply return the count which contains the total number of nodes present in our linked list. So I hope so that you came to know that how we can count the total number of nodes present in our linked list. Just in case if you are new to our channel, do subscribe the channel for more such informative videos.